One topic that I think would be a really good addition to this course, especially because of all the work we did on orbits and how planets move, would be stars. What things orbit around most stars. And one thing that I learned in my high school physics class that really stuck with me is stellar spectroscopy. It's just a small aspect of everything we know about stars, but a really important aspect. And the first thing we really need to understand when we're going to tackle stellar spectroscopy is how light interacts with matter. And basically, it can interact in three ways. And the first way it can is through reflection, and light can be reflected off of matter. And, that's how we perceive things visually. That's how we see things. Light reflects off the object and hits us in the eyes, and that's the color it is, and that's how it looks. And then it can be transmitted, and it can actually pass through the object. Like light can pass through liquids and gases and through glass. And then it can also be absorbed into the object. And oftentimes when it's absorbed into the object, also light can be emitted from that same source, can be absorbed and then released back into the universe. And so what happens when you take light and you shine through a spectrometer. Basically what a spectrometer is it's just like, it can be a little tube or whatever, and there's a filter in it. And what that filter does when the light travels through is that it shows all the wavelengths of the light that's going through. And see, this is a continuous light. So when it shines through the spectrometer shows all of the possible wavelengths that it's showing through, and basically the whole spectrum of visible light. And so the real usage of the spectrometer comes when you take light and you shine through a gas. And you see here we have some hydrogen gas and the light shining through the gas and then into the spectrometer. And you see the light spectrum looks a lot different. It's got these black lines that are going through it. And why is that? Well, what's happening, like I said before, is that most of the light is being transmitted and it's being displayed on the spectrum. But some of the light isn't, and those are where the black lines come from. And that light is being absorbed by the gas. And what we can do now is that we can determine what type of gas the light is going through by looking at the spectrum and saying, oh, these lines are missing. Now we know that this is hydrogen gas. And I'm not really going to get into the main difference between diffraction and absorption because, it's very complicated, kind of out of my realm of knowledge. But basically the difference shown right here, the difference that we need to know is that when light passes through gas and then to spectrometer, and its absorption spectrometer, it's got an absorption filter, it shows what we've seen before on the previous slide, absorption spectrum, which is all the light waves that transmit through it except the ones that get absorbed. And the emissions one is, you see on the side, you don't take it from the light straight on, you take it from a different angle. And why do you take it from a different angle is because we don't want the light that's straight on, we want the light that's being absorbed and re-emitted back out by the gas. And you see we get only certain few wavelengths that get re-emitted by the gas because only a few get absorbed. And if you compare the two, you see that they fill in the gaps. The ones in the emission spectrum fill in the gaps of the absorption spectrum. So it's really just the same thing, just shown in a different way. Now you might say, Luke, that's all fun and dandy, but like, what does this have to do with space? And now I'm going to tell you what this has to do with space. And now if you think about, so see, this is the sun right here. This is our star, the sun. Now, what is the sun made out of? It's made out of gas, and it's light, very bright on the inside, and there's gas. It's like the whole thing's made out of gas, but there's gas on the outside. And what's happening is the light shines through the gas that it's made of, and goes to Earth. The light shines on Earth. And what we can do is we can take a spectrometer and point that baby at a star, and then we get this absorption spectrum, and this is the absorption spectrum of the sun. And now see, obviously there's a lot of wavelengths that are getting absorbed in the gas by the sun. You see there's a lot of lines, and it's not just one element, it's not just hydrogen, it's a lot of elements. And what we can do now is we can take this and match up what elements are being absorbed by the sun, and that's what the sun is made of. We can determine but from our own home planet, we can determine what the sun is made out of. And we don't have to just do this for the sun. We can do this with every star that we can get a good angle on. And, this is how we determine information about these stars that are so far away without ever being able to get close to them whatsoever.